So quarter after, we'll go to part 2. Hello. We are reviewing by doing an electric field where we had 2 charged particles, this one negative and twice the strength of this one. And we threw some particles at it, and we traced these particles that I'm throwing at the board are all positive. So we are tracing the possible paths, and we learned that a positive charge will always go away from a positive, so it will go in like this. And the negatives will, positives will go toward the negative like this. Notice there are twice as many arrows into this charge as there are out of this one. So that always happens in proportion to the strength of the particles. When we finished electric fields, we took in 2 new equations. Here's one and here's one. You've already seen this one. And now we're finding this E stands for the strength of the electric field. And here we are wondering, what is the strength of the electric field at that point? So we just found out. We're going to use this equation to find out. So, Zach, you picked the equation. Now tell me what goes in for the various parts.
9 r squared is 1.5. 1.25 squared.
Oh yeah, half, because it's only half the distance, so 1.25. And what's the Q?
You're going to have to do 2 of them.
Pardon?
You're going to have to do 2
yeah.
equations. So
right, so we're doing that's why I have the brace here first.
For 1.
1. Alright, because the charge is 1. Alright, so over here, Alex set up the same thing that he just did. We're going to use the equation again, but this time we're between these 2. So what will change, if anything? So what goes in for K?
9.0 times 10 to the 9.
And Q this time, or not, Q is the strength of the positive.
Negative 2?
Yeah. It's the strength of the stationary particle.
And the bottom will stay the same,
yeah.
1.25.
Alright, tippy tap. I need some numbers. Anyone got the left one? MK? Alright, anyone confirm?
Man, I couldn't even do it as fast as she did.
Alright,
I like blink when
and
she's
that's in
done.
newtons per coulomb. Alright, and anyone got the right side? Zach?
I
got a weird number.
I got 1.15.
Yeah, so I got 1.152 times 10 to the 10.
1.15 times
10 to the 10th.
That's right, guys. Oh, I thought that's the final thing.
That's what I got, Brick.
Alright, so now we have to go back and figure out which way these are going. So on this one, since this is a positive charged particle and this is being, the electric field is being created by a positive charge, this is the strength of it, but which way should I draw the vector?
To the right.
Okay, so that's the 5.8 times 10 to the 9. If I can squeeze it on there, not very clearly, let me do a better job. 5.8 times 10 to the 9. Alright, so MD, this one, which direction will this strength be pushing the charge, the test particle?
To the right.
Alright, because this is positive, this is negative, so there's an attraction, so it will also go this way. And that is at 1.2 times 10 to the 10th. So Brian, since both of the vectors pointing to the right, what will I do with them? Mathematically, will I subtract them or add them?
I mean, is there ever really going to be a time and they don't point in the same direction?
Yeah.
It's good. I'm good at 11.
I guess we have 2 equal.
Exactly, that's right.
I know, that's how I am.
So,
I really like my bed.
So adding these 2, 5.8 times 10 to the 9, and 1.2 times 10 to the 10th. Did anyone get 1.8?
Times 10 to the 10.
Yep. And that is newtons per coulomb, and it's, you have to tell me it's to the right. I need a direction.
Probably the drugs in the system.
Alright. Can you do that to Mari?
Yeah.
Alright, the next step, I'm going to leave that up because the problem is the same. I can erase the electric field. Now I want to know, in the exact same example, I want you to find the electrostatic force, F sub E, at when I give you a charged particle that the charge is known. So let me show you what I mean. All this showing up on the video? Pretty good, Alex?
Yes.
All this showing up?
Oh, yep, it's all good.
Alright, onward with that. Let's take the same scenario, +1 coulombs, 2.5 meters, and -2.0 coulombs. And this time I'm going to give you a charged particle that has this charge. Actually, I'm not putting this particle that I'm putting there, so I can show you they're not always positive, is if I tell you it's negative, I can put any particle I want there, but if I don't tell you, you're just going to assume it's a test particle that's positive. But this time I'm going to put in a -0.66 millicoulombs particle there, and that's its charge. And I want you to find the electrostatic force. Now we did that earlier in this chapter by doing this side and then this side, but there's a quicker way now. So we're going to use, so Zach, what formula will get us there quicker than that? Right, the one we haven't used yet. E equals force electrostatic, which is what I'm looking for. I'll circle it. And now the test particle is known. On this one, unlike the other two, we do need to put the sign in, the SIG. We need the sign so we know at the end which way it's going. Because we're not going to create two vectors and be able to observe which way it's going. We're going to need to know from the math which way it's going. So we need the sign included in this one. We do not need the sign included in the other one. So that's why I put a negative in there to make sure you do that as well. So what values do I know?
You know the 1.8 times 10 to the 10th is E.
Okay, and that came from all this Q struck over here. We have the electric field already from our previous board work. So we have 1.8 times 10 to the 10th, grabbing it from over there, equals, and because it's to the right, I'll call it positive. All right, so what else,
We have the negative 0.0006.
Right, and that goes here. It's our test particle, or our particle that we're interested in. The only thing is I want to work in coulombs. So what do I do with this decimal?
Move it 3 times.
Which way?
To the left.
All right, so it's a minus 0.00066. And so mathematically, what do I do?
You multiply.
Multiply. So 1.8 times 10 to the 10th times negative 0.00066. And I'm going to get a negative number.
Do you keep it as negative?
Yeah, well, what that tells me is which way it's going, so I'll show you 2 ways you can tell me. All right, anyone get 1.2?
Times 10 to the 7th.
Times 10 to the 7th.
Yeah.
And this is a force, so we're in newtons again. So you have the choice. You can just say negative 1.2 times 10 to the 7th, or you can say 1.2 times 10 to the 7th to the left. So that's telling me the same way. But if you didn't put the negative sign in here in the beginning, you wouldn't know which way it went. So you'd have to go back and do it the long way, using this twice, once for this side, once for that side, see which way they go, and then adding or subtracting them. This is so much faster if you include the sign, so at the end you know which way it goes. All right, so that's our gist. That's our prep for for tomorrow's big quiz. So you have to recreate this with a problem just like that. No tricks. No tricks up my sleeve. All right, we'll end today. And I'm sure you were wondering, as I was as well, how fast an electron goes. So, were you wondering how fast an electron goes?
Oh, yeah.
I wonder that all the time.
Yeah.
I know.
I laid in bed last night thinking about the electrons.
I knew it. I knew
Rob,
it.
you
You will
voice.
sleep well tonight
I will.
because you're going to figure that out.
Electrons. I'll die in peace now. Knowing the speed of an
Why are you
electron.
planning on dying tonight?
I don't know. She's not gonna make it to Friday.
So you
She's not gonna make it to
paycheck.
Saturday.
Just so proud.
I gotta fill my paycheck and then Saturday I make it to turn on my squad one final time and then Sunday I can go. She's gotta make my squad hang out.
Wait, you gotta go to church too on Sunday.
Okay, I do right after it. So now we go. That'd be the best way to die
I
though.
know my 2016. Even if I miss it.
Let me give you an electron, set up an electron for you, and did you get your paper? Whose is that? Oh, that's just extra.
Yeah.
I'll take it then. We don't need it now.
And write that down. Should you pause this
The
video?
simplest electron
following.
configuration is on the hydrogen atoms. Do you recall how many electrons are on the hydrogen atom?
8.
No.
6.
1.
Thank you. It's the
Ah, I got him.
Guys, chemistry.
Yeah, come on, dude.
Chemistry was
I
my
blocked
least
that out of my head.
I was going down in numbers too. It's going to get
All
close
right.
to 1. I'm like 4, 2,
We start
1.
with the simplest case. Hydrogen has 1 electron and 1 proton. And I'm wondering, as you are, how fast that electron is
Tries
going.
online. You do
We
50% off
know
all
some
week.
things about this atom. We know the radius. The radius of this atom is 5.29 times 10 to the what, do you think?
Is it 10? Or is
No,
it
it's going to be small. That
One?
is a
Oh.
huge number.
10 to the second?
No, it's going to be a
Negative 13.
negative number. Negative
Ne-
13, that's a good one. It's negative 11.
What's the better section? Oh, I've heard negative 13.
So we have the radius of the hydrogen atom. And I know the actual Q of, I know the charge of an electron. I gave it to you earlier in your notes. Negative 1.6 times 10 to the what?
Negative 26.
Almost. Negative 19. And that's coulombs.
Coulombs.
And so that's the charge of the electron. The charge of the proton, do you know that? Even though 1 is so much bigger than...
1.6 times 10 to the 19.
Right, so it's the same but positive, which is a miracle in itself since 1 is so much bigger than the other. And I know the mass of an electron. So this, we come to the table knowing all these things. The mass of an electron may shock you though, 10 to the what? Give it a good guess, MK.
Negative.
Not too bad, 31. Very, very
So excited for
small.
next week.
So we have all of our charges and the mass that we need and the radius. So get down all that. And now all we have to do is figure out which equation will have the speed. I don't see anything up there with speed, with velocity, do you? But there's something in your brain that has the speed. When something goes around something else, what kind of force is that from the past?
Oh,
Circular?
It is circular.
Circular
What
motion?
We called it, what?
Circular motion?
Then
It
Centripetal
starts with
force.
this- That's it, centripetal.
Force.
All right. You've been
Yeah.
studying for the final.
Boom.
haven't
you
you?
just
I sure have.
I've seen you. I feel like
Did you really?
subconsciously.
In the
You said it, I
past,
didn't hear you say it.
we have seen in
Fine.
centripetal force provided by gravity, tension. Hello?
Hi, can I have Alex to the office real quick, please?
Okay, real quick. All right.
Presidential campaign.
Oops, we went over time. Can we shut that down?
I'm sure.
Just you can close that or push the button.
Yesterday she used my name to see our blur.
Okay.